Hi, this is Tag again, and today I want to talk a bit about this here ABIT board and socket 423 in general. Now, socket 423 was a really short-lived first socket for the Pentium 4. They had these here Vmem chips that are basically, well, that package here is slightly smaller than on 478 on a huge second PCB. Let's open this one. There you go, looks like this. Now, these things were notorious for being slower than the Pentium 3s basically. And overclocking is also not really that great on them. But anyways, today I want to show you the voltmods on this here ABIT board. In my opinion, this is the best, or at least one of the best 423 boards. Now there is one significant limit with this. The clock gen here only goes to 156 MHz, which is also the case on its direct competitor, the Asus P4T here. I don't like this board as much as the ABIT one, but then again this isn't modded yet, so that might be the reason. Anyways, there is one board that can do more FSB, and that would be the Asus P4T-F. Unfortunately, I've never seen one of those. They have the memory slots like 2 up here and 2 on this side. Those apparently do more than 156. They must have a different clock gen on there or something. Now, this is your typical volt mod here. Let me zoom in. We have our little VRM controller here and usual feedback pin stuff. That's my monitoring, my variable resistor here. Now on these, if you run them on the extreme cooling, you also need to do a overvoltage protection mod to get rid of that, because otherwise it has overvoltage protection at about 2.1 volts, which isn't all that much for these Vmem core Pentium 4s. Anyways, I'm going to show you that in detail afterwards. There's also 2 volt mods I have done here, but I haven't yet really used that much. That's the bottom one is Meassuring Vtt and the top one is memory itself. I should probably write on those variable resistors here. Anyways, there is a strange little zoom in controller here. Now this is a bit of a, well, package deal, I guess. This is one VRM controller for a switching VRM here, and then there is 4 outputs for basically linear regulators. So they use these FETs as linear regulators. There is this one here is the Meassuring Vtt, which I modded as well. Then there is this one, which I presume is Southbridge power. And also this one, which regulates 5 volts down to 3.3, and I presume that's something with the IDE. I'm not quite sure, or floppy rather. I'm not quite sure what that thing is for, but those don't matter. I'm going to show you the pins for it, but I don't think anyone wants to mod those. The 2 up here are your. Again, I have not tested these yet because, well, I haven't done any serious RDRAM overclocking, even though these should be decent DIMMs. Let's check. I think these are, yes, these are the Samsung 1066 MHz. So that's basically, if you ever want to buy some random RDRAM or see them in a lot or on the scrapyard or something, look out for the 1066 Samsung ones. Those are basically the best ones you can get. There's also OCZ 1200 MHz kit, which is super rare, but that's also just bin Samsungs, so there's not really much difference. Anyways, besides the volt mods, what I've done to the board is, as you can see, all aluminum polymers, and there's even more fancier stuff on the back. Now, this is my little improvement on the CPU Vcore VRM. those are 10 470 microfarad SP caps, then a row of 1206 MLCCs and a row of 0805 MLCCs. I added all of those. Now, it seems to have helped because I was able to do almost 3 GHz on Cascade with this chip, which is the highest core clock on 423 ever. And I also took, I think, W prime and pifast records. In SuperPi I was lagging behind because, I don't know, maybe VAS are not working, maybe my OS being garbage. Anyways, I also added some MLCCs on memory. As you can see, there is like a row of MLCCs, and those are 2 tantalum polymers. Unfortunately didn't have any SP caps because those have to be rated for 4 volts or more. Those are J, so those should be 4 volts. So don't just slap 2.5 volt on here, because 2.5 volts is the exact voltage you're running. So if you overvolt the memory at all, you're going to be out of spec there. That's my sense wires here. Oh, I should mention, for your sense, these 3 caps here are your memory VTT. As you can see, I have my sense wire here, and then there is a bunch of memory caps all around here. Basically all of these I think are memory. These might be Vcore, I'm not sure. There is a bunch here I already replaced. Safe bet would be these big ones here. Those are directly after the memory VRM. Anyways, in general, I wouldn't, well, I can't really help you with RDRAM overclocking at this point because, well, or voltage tolerance or anything like that, because I haven't tried myself. I eventually want to try, but likely on a different board. There's also ABIT TH7 too, which is socket 478 and is stronger for memory and more modern and everything. So unless you're going for 423 records, then get one of the 478 RDRAM boards. If you just want to mess with this really strange memory. Oh, also one thing I want to mention about RDRAM. RDRAM needs all slots to be populated, so you either have to put in memory modules or these little, I don't know, dummy terminator whatever thingies. Mine came with the board, that's really nice. And it also leads to a lot of C1 postcodes, because if you have one bad contact basically on any of the memory slots, unless normal modern platforms or even any DDR platform basically, it doesn't drop channels or slots, it just doesn't post at all if not all 4 are perfectly inserted and like make perfect contact. It's really annoying about these. Well, I'm going to do a video on this one separately, I think. I wanted to do it today, but I don't really have the time to figure out all the voltmods again, because, well, there is basically no documentation on any of this, so that's just a whole bunch of probing around on the board. Well, CPU Vcore is usually super easy on these, but stuff like the memory and finding other rails on here. I still haven't found Northbridge voltage, for example. It's likely this FET here, but I haven't found the controller yet. There is a trace here, that's the gate of the FET, and it's running as a linear regulator basically, and this trace here disappears here in the PCB. So I have no clue where this goes. I have to search for a chip that looks like it could drive a FET somewhere on the PCB. I might, I might add the mod in the description or something if I figure it out, and especially if one of you really wants to know it, just ask in the comments and I'm going to spend some more time another day and like post a link to a picture or something to basically show you that last mod that this board is missing. Also, this might also be AGP power, in which case it's kind of useless. In which case I'm a bit confused where the North bridge on these things draws power from. Anyways, I think that's about it. I will now continue to the computer and paint and show you the more detailed overview of these mods.
Okay, here we are. Now let's start with the Vcore mod, because this is both the easiest, I would say, and the most useful. There is basically two versions here. One is without removing overvoltage protection, and one is with removing overvoltage protection. Now let's start with just a regular volt mod. Now the stock BIOS maximum for this board is 1.85 volts, which I would say if you're on like air cooling is probably already enough, but on stuff like water and like starting with single stage or chilled, you probably want more than that. Anyways, let's start with the mod. The regular one would be one of these two pads. Grab your variable resistor. Yeah. And put that to ground. Now, for a value, I would recommend about, let's say, 10 to 20 kilo ohms here. 10. Now, if you're doing, I missed something. If you're doing the mod without removing overvoltage protection, I would recommend using the high end here. So 20 kilo ohms. And if you do it with overvoltage protection, which is pretty easy, you just want this Vcent pin here, which is also on these two pads. And you just parallel those two. So I just soldered the bridge across here. With this, basically your resistance to Vcore is lower because you have two pins. And I think they have the same resistor towards Vcore. Anyways, you basically parallel two resistors towards Vcore, so you want a lower rated potentiometer to make up for it. So you don't lose too much like fine adjustability of the voltage. So I would recommend using a 10 kilo ohm or maybe, I would say 10 kilo ohm for the mod if you do the OVP removal as well. Anyways, the ground points in this area would be these two. Those are easily accessible. Then just use your tabs from the audio header or the bottom of this cap here, the bottom of this cap here, and there's also a screw hole up here. I can't write in paint, sorry. Anyways, there is a screw hole up here. That would be your other option. I personally soldered it to one of those tabs of the I/O. I think I used serial port or something that is like way up here. Anyways, it's basically your Vcore mod. When I ran the CPU before, I hadn't yet figured out the overvoltage protection, and I was basically stuck at 2.1 volts for my 3 gigahertz attempt. I think I will redo with overvoltage protection and probably LN2 as well someday and see if I can get the first 3 gigahertz on 423 out of this thing. Anyways, let's move on to our, well, next picture, I should say, because it's not just one mod. Also, let's zoom in this a bit so you can see it more detailed. I will zoom in the next one right off the bat, I think. Sorry for that. Anyways, here is the next one. That's actually pretty good already. Yeah, something like this. Is there anything below here? No, there is not. Okay, so let's get started on here. Let's start with the one that is just your good old memory mod. Memory feedback pin is this one here. which you can also grab from this capacitor here. And here it's basically more of the same. It's just a variable resistor towards ground. So like this. Bit thicker. Towards ground. There we are. Now, for a value, I would go pretty high here because I have yet to basically test the voltage tolerance of RDRAM. So I would suggest for now use something like 20 to 50 kilo ohm variable resistor for that one. Now let me do a quick overview of this thing, just in case you want to mod it. This is what I presume the south bridge voltage feedback on this, and this one here would be the one for this odd 3.3 thing that I don't know what it's for. So in the vast majority of cases, actually, you're probably fine ignoring what I just said anyways. Let's move on to VTT. I also don't know how much VTT does on this, so this is more of a mod for, well, for you to try, I guess. It's certainly not going to hurt it if you put a relatively high one, high value variable resistor on here. Anyways, usual stuff, variable resistor towards ground. Here is the same. I personally used 100 kilo ohms here, but I think you can get away with something like 50 to 100 kilo ohms here. The stock resistance on here is like 4.7, I think, 4.7 kilo ohms, and my usual formula is like use 10 times the value for voltmods. So you, according to that formula, you would be fine with 50, but I don't want to raise the voltages on the RDRAM too much because it already gets super hot, because it's RDRAM likely, but anyways, that's why I use the 100 kilo ohm on here. Now, I think that's about it. These two, I'm not going to show you a mod, but in theory, if you would ever want to mod these two, it's the same principle. Variable resistor towards ground will work fine. As for grounds here in this area, there is basically nothing. The only good ground would be the screw hole I used here basically. It's out of the picture here. You can see it in the video itself. Now I want to move on to something. Well, let me show you. Just the measuring points so you can remember them easier, because I'm not sure how clear you could see them on the video before when I showed it on the camera, because, well, my lighting is not that good, and also that thing is out of focus half of the time. Anyways, these are your VTT caps. That's VTT. VTT. Memory VTT at that. They go up here at some resistors towards memory. This one is not memory. This one is what I presume North Bridge to be. So ignore that one. That's connected to this pad here. Then this one is your presumed South Bridge filtering cap. I say presumed South Bridge because there's basically a power plane that goes like right down here, something like that, from other pin actually. Right down here, like looks something like this, I think. That's why I presume it to be South Bridge. Also, I probed the HEP slot and it wasn't there. Go away, Windows. Just for your knowledge, basically, because you can easily confuse this with the VTT rail because they're both basically 1.8 volts ish. Now, unfortunately, on this picture, you can't see the capacitors for Vmem. So for that, just refer to the video before and hope that I didn't fail too badly at showing it. Anyways, just for your interest, this is the strange 3.3 volt regulator down here that's also connected to the same little VRM controller. I think that should be about it on this board. There's a bunch of useless information in here, I think, but I hope you enjoyed it, and if you have one of these rare things and, well, you don't feel quite comfortable enough to mod them after this video because I missed something, feel free to ask. I will try to answer your questions as soon as possible.